When you hear the word data, what's the first thing that pops into your head? For a lot of us, it's probably a massive spreadsheet full of numbers. But, data is so much more than that. It's really a collection of different types, and each one has its own personality, its own rules. So let's dive in and really get a handle on the fundamental language of data science. All right, here's our game plan. We're going to start with the two main families that all data belongs to. Then we'll zoom in a little closer and look at the key difference between counting things and measuring things. After that, we'll climb what I like to call the ladder of data precision, the 4 levels of measurement. Then we'll see how this stuff actually gets used in research, and finally, we'll tie it all together to see why any of this actually matters out there in the real world. So let's kick things off with a little puzzle. On the surface, you see the number 5 in both of these, right? A 5-star rating, a 5-degree change. But are they telling us the same kind of thing? It seems so simple, but there's a really interesting difference hiding in there. By the time we're done here, you'll know the answer, and it perfectly sets the stage for everything we're about to unpack.
Okay, so first things first. Every single piece of data you will ever encounter, no matter how complex, fits into one of two big families. Getting this first split down is absolutely the most important starting point.
And here they are, qualitative and quantitative. Honestly, the easiest way to think about this is that qualitative data answers what kind, and quantitative data answers how much or how many. One is for describing, the other is for measuring. That's really the core of. So let's look at qualitative data. You might also hear it called categorical data. It's all about labels, descriptions, and putting things into buckets. Think about the color of your car, your gender, the brand of your phone, or even if you're satisfied or unsatisfied. All of that is qualitative. Its job is just to sort and label. And on the other side of the coin, we have quantitative data. This is the stuff we're probably more used to thinking about, the numbers you can actually do math with. Things like your height, the temperature outside, your age. If it's a number that stands for a count or a measurement, you're looking at quantitative data. But wait, it gets a little more interesting. Inside that big world of quantitative data, there's another split. Because you see, not all numbers are created equal. You'd think a number is just a number, right? Well, not exactly. Let's dig into the two very different types of numbers. And that split is between what we call discrete and continuous data. The simplest way to keep these straight is to just think counting versus measuring. You count the number of cars in a lot, that's discrete. You measure the speed of one of those cars, that's continuous. So discrete data can only be specific whole values. You can count them. Think about the number of people in a room or the number of eggs in a carton. You can't have 23 and a half people, right? So the little mental check is super easy. If you can count it, it's discrete. Continuous data, on the other hand, can be any value within a range. Take your height. You might say you're 180 centimeters tall, but you could be 180.1 or 180.15 or 180.152. The precision is only limited by how good your measuring tool is. So for this one, the test is just as simple. Can I measure it? If you can, it's continuous. Okay, this is cool. We've sorted our data into its big families, and we've even split our numbers into two different types. But what if we want to get even more specific about what our data can tell us? Well, that brings us to the real heart of this whole explainer, the 4 levels of measurement. This is a framework that tells us just how much information each piece of data really holds. I always think about these 4 levels like climbing a staircase. Each step you take up, from nominal to ordinal to interval and finally to the top at ratio, adds a new layer of detail and unlocks more powerful analyses you can do. So let's start climbing. Down here on the ground floor, we've got the nominal scale. This is data that's purely for labeling things. We're talking brand names, hair color, types of cars. There's just no meaningful order to them. You can't really say that red is somehow greater than blue, right? The key question to ask yourself is, can I order these in a meaningful way? For nominal data, the answer is always a big fat no. Now we take one step up the staircase to the ordinal scale. Here, the order is everything. We all know a 5-star rating is better than a 4-star rating. We know a master's degree is a higher level of education than a bachelor's. But, and this is the important part, we don't know if the difference in satisfaction between a 1-star and a 2-star review is the same as the difference between a 4-star and a 5-star review. Those gaps between the ranks are uneven, or at least we just don't know. Okay, next step up, the interval scale. Now, this is where it gets really interesting. Not only do we have a meaningful order, but the gaps, the intervals between the values are equal. Temperature is the perfect example.
The jump from 10 to 20 degrees is the exact same amount of heat as the jump from 20 to 30 degrees. But, and here's the catch, there is no true zero. Think about it. 0 degrees Celsius doesn't mean there's a complete absence of heat. It's just another point on the scale. It's just cold.
And finally, we've reached the top of the staircase, the ratio scale. This has everything the other levels have, order, equal intervals, but it adds the killer feature, a true, meaningful zero. Here, 0 actually means nothing. 0 kilograms means a complete absence of weight. $0 means no money. And because of that true zero, we can finally make ratios. We can say that 60 kilograms is literally twice as heavy as 30 kilograms. That's something you just can't do with temperature.
So we've taken this whole journey through how to classify data, but how does this get used in the real world? Well, when you're doing research or running an experiment, you stop calling them data types and you start calling them variables. And pretty much any experiment you can think of boils down to two main players. You've got the independent variable, or the IV, that's the cause. It's the thing a researcher is deliberately changing or testing. Then you've got the dependent variable, or DV. That's the effect. It's the outcome you measure to see what happened. Cause and effect.
Let's make this super concrete. Say you want to test if the number of hours you study affects your exam score. Well, what's the one thing you are intentionally changing to see what happens? It's the study hours. That's your independent variable. The easiest way to find it is to just ask, what am I changing? And what's the other side of that? The dependent variable. In that same study, what are you measuring to see the result of your studying? Your exam score, of course. The score depends on how much you studied. So, to find the DV, all you have to do is ask, what am I measuring to see the outcome?
Phew, we've covered a lot of ground, right? From the big families of data all the way to research variables. But you might be thinking, okay, that's nice theory, but why does it actually matter if something is nominal or ratio? Let's bring this all home and see why this is so critical.
Knowing these data types is everything because it tells you what you can and, more importantly, what you can't do with your data. In a hospital, a doctor knows that blood pressure is a ratio variable, but a patient's pain level on a scale of 1 to 10 is ordinal. They require totally different analyses. A market researcher can't calculate the average brand preference because it's nominal data. That doesn't even make sense. Knowing your data type is always step one before you can draw any meaningful conclusions. And that is the power you have now. You've learned the fundamental language of data. You can look back at our original question and know, without a doubt, that a 5-star rating and a 5-degree temperature change are worlds apart. One is ordinal, the other is interval. So the real question is, now that you speak the language, what stories are you going to be able to find and tell with data?